Yeah.
My God. Just a minute.
Hello, Ingo.
Yes.
Marco, hello, Neven.
Hello.
Hello.
Okay, so we have Ingo. I think we're all there. Ingo, just before, so the speaker for the invited lecture said he tested his connection before. He will connect 5-10 minutes before the lecture starts. So
I lose my presentation.
Okay, Rita, calm down.
Okay, it's fine now. We can start.
okay. Let me just, so I will just ask everyone to mute the mics.
Can you, Rita, can you start the presentation?
Yes,
Maybe.
for sure.
Okay.
Dear colleagues, professors, lecturers, researchers, and all attendees, good morning, good afternoon for all of you. I'm Rita Alves, chair of the local organizing committee, and I would like to express
Rita, maybe just wait a second because we have to let people in.
Okay.
Let's wait another minute.
Then you tell me.
Okay, I think you can start now.
Dear colleagues, professors, lecturers, researchers, all attendees, good morning, good afternoon. I'm Rita Alves, co-chair of the local organizing committee, and I would like to express my sincere gratitude and welcome you to the third SDEWES LA, Latin America Conference on Sustainable Development of Energy, Water, and Environmental Systems. I honorably welcome our today's speakers, Dr. Reinaldo Giudice, Director of the Escola Politecnica, Dr. Giulio Meneghini, Scientific Director of the RCGI, the Research Center for Greenhouse Gas Innovation, Dr. José Carlos Mierzo, Head of the Department of Environmental Engineer at the Escola Politecnica, USP, Dr. Neven Duit, President of the SDEWES Center, Dr. Paulo Artaxo, Professor at the Department of Applied Physics at the Institute of Physics at USP. The SDEWES conference accounts for the 17 editions for the main conference in Europe, 5 editions in Southeast Europe, and 3 editions in Latin America. The SDEWES conference are dedicated to improvement and dissemination of knowledge on methods, policies, and technologies for sustainable development by decoupling growth from natural resources and replacing them by knowledge-based economy, taking into account its economy, environmental, and social pillars. Thus, it's my hope that the third SDEWES LA would be able to achieve its objective and provide an effective forum for academics, researchers, and practitioners to advancing knowledge, research, and technology for sustainable development. The focal drive of this conference is to exchange ideas, and by participating in this exchange, it is hoped that all parties who may benefit from the conference can apply it and manage activities in their area. It is pleasing to note that the agenda of this conference covers a wide range of interesting topics related to all theoretical and practice aspects of sustainable development. My deepest gratitude goes to the main organizers of this conference, the University of Zagreb, the Instituto Superior Técnico, the Universidade de São Paulo, and the SDEWES Center. All to the Scientific Advisory Board, to the organizing committees, to institutions and companies for their sponsorship, and to the participants coming from 25 countries, 50 cities, and more than 55 universities, institutes, and companies. To Dr. Luis Colai, who is co-chairing the local organizing committee with me, and to the volunteers who have directly and indirectly supported the success of this conference. The committee has organized a vibrant scientific program, including lectures and discussion panels, and worked hard to present high respect and internationally notorious speakers to lead it. The papers submitted as archival may be candidates for publications in special issues of several partner journals, among them Renewable and Sustainable Energy Reviews, Applied Energy, Renewable Energy, Journal of Environmental Management, Energy, Clean, Technology and Environment Policy, and so on, and also to the Journal of Sustainable Development of Energy, Water, and Environmental System, whose editor-in-chief is Professor Nevin Duich from the SDEWES Center. It's a journal from the SDEWES Center. At least, I wish you a very productive conference with exciting and encouraging discussions and exchange of knowledge concerning the sustainable development. Have you all a successful and enjoyable conference. Thanks. Thank you, everybody. Professor Dr. Reinaldo Giudice to give the welcome in the name of this Polytechnic School. Professor Reinaldo is full professor and currently he is director of the Escola Politécnica USP. He has experience in chemical engineer with emphasis on chemical reactors, working mainly on mathematical modeling, process simulation and optimization, chemical reaction engineering, polymerization reaction engineering, and he is also editor-in-chief of the Brazilian Journal of Chemical Engineer and member of the advisory board of the main funding agency in Brazil. Professor Reinaldo, please.
Thank you, Rita, for the kind introduction. Good morning, everyone. I'd like to express my great pleasure to take part of this opening ceremony, and I'd like to congratulate all the participants and speakers of this third Latin American Conference on Sustainable Development of Energy, Water, and Environmental Systems. Sustainability is now clearly a fundamental part of all engineering activities, and energy and water are fundamental basic needs for the humankind, and you are now challenged to produce and distribute and provide these needs while preserving the environment and the planet. This year, actually next month, our Polytechnic School is completing 129 years of existence in education and research in a broad range of different branches of engineering. As one of the oldest and the leading engineering schools in Brazil, Polytechnic School of the University of São Paulo is genuinely interested in effectively contribute to the discussions, studies, and in seeking and proposing solutions for this today fundamental problem, the sustainable development. It's actually part of our mission, the mission of our school. In our school, we have several research groups working on sustainable development. Just to mention a few of them, the school hosts a multidisciplinary center for studies on greenhouse gases, including capture and reuse of CO2. This center is the RCGI, and you will have opportunity to know more about this center during the conference. This center was originally sponsored by FAPESP, the State of São Paulo Research Foundation, and by Shell, and now is being also sponsored by many other companies, especially those linked to business in oil extraction, petrochemical processes, and energy. We also have another important group working together with companies to develop more eco-efficient materials for construction to reduce the carbon footprint related to the production and use of cement and concrete. We also have several groups working on treatment of wastewater, in particular facing the problem of persistent pollutants, remediation of polluted environments in soil, water, and air, and groups working on improvement of life cycle assessment tools. Polytechnic School is very proud to take part of the organizing committee of this conference, and I would like to congratulate all my colleagues, professors, staff, and students of the Polytechnic School who are involved in the organization of this conference. I'm sure that this event is joining the best science that can effectively contribute to the state-of-the-art of the innovative technologies to address many of the current problems in sustainable development. I wish you an excellent conference with fruitful and inspiring discussions. Thank you.
Thank you, Professor Reinaldo Giudice. Now the next speaking, Dr. Giulio Meneghini. Dr. Giulio Meneghini is full professor of applications in principles and mechanical engineering at Escola Politecnica, USP. He is scientific director of the RCGI, the Research Center for Greenhouse Gas Innovation, hosted by USP and sponsored by FAPESP, the São Paulo Research Foundation, and Shell Brazil. Professor Meneghini is author of more than 130 published scientific papers. He has coordinated research projects sponsored by Petrobras, Shell, and other important companies in Brazil. He was awarded as a full member of the Academy of Sciences of São Paulo State. Professor Giulio.
Well, thank you very much, Rita. And I'd like to welcome all of you, and I'd like to thank the organizers of this conference. And I have a short presentation, Rita. Can I just put the short presentation?
Yes, for sure.
And, yeah, okay. And then it's really a pleasure to be here. And as Professor Reinaldo Giudice just said, we are in a very particularly important moment in the history of mankind or humankind. It's better to say now humankind, and the focus of this conference is exactly related to the point to give solutions to this main problem nowadays that is going to affect the whole humankind for the decades to come. That's climate change and things related to sustainability and all chemical engineering process and so on are the key answers to that problem. Well, I don't know if you can see the first page of my presentation. Can you see?
Yes.
Yeah. Then what Professor Reinaldo just mentioned, our center, and our center is a center devoted for research in greenhouse gas innovation, greenhouse gas and innovation, and focus on the reduction of emissions of such gases. And then what we have for that, this is just what I said. And when you think about reduction of greenhouse gas emissions, Brazil can play a very important role. And what we intend to do is to try to help the Brazil and the Brazilian government and the Brazilian society to achieve our NDCs, the nationally determined contributions for climate change. And then how we work? We work in a triple helix model. And in this triple helix model, we have academia, industry, and government. Academia, as José Reinaldo mentioned as well, Reinaldo Judice just mentioned, academia, we are hosted at the Escola Politécnica of University of São Paulo. And we have not, we are hosted, our headquarters are at the Escola Politécnica, and we also included many other units of University of São Paulo and other universities in Brazil as well. And as Reinaldo mentioned, the industry, we have Shell, we started with Shell, but we have now Repsol, Sinopec, we have Petronas, Eneva, that's a Brazilian energy company, and other companies to start working with us now. Our current budget, considering the past 6 years, and the budget that we are still spending is about 250 million reais. It's about $50 million, a little bit less than $10 million per year. And when we talk about government, it's FAPESP, it's São Paulo Research Funding Agency. And just some very big numbers about our center. We have 69 research academic members of staff and plus postdocs and PhD students and so on. And then these are the numbers from last year's. We have patents that were applied. Rita Alves is the author of one of the patents. People from University of São Paulo also are inventors of other patents that have been filed. And more than 500 papers in conference, more than 300 papers in research journals. This is in the past 5 years. And regarding the composition of our center, we have now 70% of males and 30% of female. And when we talk about this number, we are trying to improve the number of female research working in our center, having some sort of inclusion program being developed. And we have more than 10% of researchers coming from abroad, from different countries in the world and different continents. And if we talk about that number, 69 academic members of staff, and if we add the others, the postdocs and so on, it goes to a number that it's close to 400. And then we, all the projects that we have, currently we are starting the 77th project. We had 36 projects that have already been concluded, and another more than 42 projects that are still running, and some that are starting now. And all those programs, they have to have a clear link with the Sustainable Development Goals of the United Nations. And then if we take those 76 projects that were concluded or are still running, we have the SDG 13 and 7 are the ones that are most correlated, and climate action for sure, and affordable and clean energy. But apart from those SDGs, all others, in some sense, we have the projects have been some sort of correlation with them. And as talking about the Brazilian NDCs, we had as an NDC before COP26 to become carbon neutral by 2060 and to have a reduction by 40% in 2030. This changed after COP26, and then we are going to become carbon neutral by 2050 and becoming 50% reduction by 2030. This is a change, and even though in Brazil we have a lot of problems, a climate issue that must be attacked, the problem with deforestation, that something must be done to enforce the law, we increased the NDCs and the target to become carbon neutral. And if we talk about routes to Brazil become carbon neutral, in our center we divide in two main routes. One of them is on land, and the other of them is offshore. And then starting with the on land routes for Brazil to become carbon neutral, it's clear that Brazil must employ all the opportunities that we have, and few people know that Brazil releases pure CO2 at huge numbers just from one sector of the Brazilian industry, that's the ethanol production. And ethanol production emits about 40 billion tons of CO2, and that's a CO2 that's completely clean, pure CO2 at this rate that could be used for CCU applications, for CCS on site. And then if we use that route and try to capture the CO2 from the ethanol production and produce synthetic fuel, and together we remove diesel and other fossil fuels from the production of ethanol, and also from the fertilization, the fertilizers, if you remove and fossil fuels from the fertilizer production, if you remove all of that and use that CO2 that's released from the production, we can even have a slightly negative ethanol being produced in Brazil. Can you imagine if you drive your car and in reality you are not emitting CO2, but somehow in the global sense, you are helping to store CO2. And this is one of the routes that we do. And our center is split in 5 different programs: NBS, nature-based solution; bioenergy, carbon capture and storage is the second program; CCU, carbon capture utilization is the third program; greenhouse gas, and the advocacy. And what I just said in ethanol, there are projects in NBS to increase the rate of CO2 that's captured in the soil. If you just see the projects that we have in BECS, is exactly what I just mentioned, the example of ethanol. together with CCU, we have projects to use that pure CO2 for other use, pure CO2 that is not like flue gas. And at last, the greenhouse gases and the program that is main focusing on finding ways of engineering, using engineering to mechanical engineering process to, for instance, to reduce the emission of greenhouse gas in big compressors using topology optimizations. And another extremely important, and is the biggest project at RCGI, that's a project to map the balance of CO2 and methane emissions in the Amazon forest using different means, using data from satellites and data from, for instance, from towers in the Amazon forest and other devices, sensors, small sensors to detect, and then in real time give the mass balance of CO2 and other gas emissions. And at last, the advocacy program is the program that gives you, that tries to wrap up all those previous 4 programs in a sense that gives the social perception and all the legal and standardization programs related to greenhouse gas. And just to finalize, together with the routes onshore, there are routes offshore that a new center also sponsored by FAPESP and Shell that probably is going to start its activities next year and is going to work with those routes related to wind energy, offshore wind energy production, to do CCS offshore, to produce other chemical compounds like methanol or ammonia offshore, using all the potential and all the natural gas and oil that comes from our huge oil and gas fields offshore of the Brazilian, in the Brazilian basin called pre-salt basin, that's in the state of Espírito Santo, São Paulo, Rio de Janeiro, Santa Catarina, and Paraná. And these are just overview of some innovations that we did in our center, and all those information you can find in our web page. These are the partner institutions of RCGI, not only companies, but the colleges of University of São Paulo and colleges and universities that are not that are not part of University of São Paulo, together with the collaborations that we have with the Sustainable Gas Institute at Imperial College, CSTAR, that's an NSF center. We have an NSF center-to-center collaboration with CSTAR, and another one with POETS, that are 2 centers sponsored by the National Science Foundation in the US that has an agreement with us. And this is what I just mentioned. And thank you all, and you are very welcome. And thank you for inviting me for this presentation. And my wishes are that you all have a very, very productive event this week. Thank you, Rita.
Thank you, Julio. And now we have a pleasure to invite Professor José Carlos Mierza. Dr. José Carlos Mierza is professor and head of the Department of Environmental Engineering at the Escola Politécnica USP. He has experience in the area of project and process of water and wastewater treatment systems, water conservation and reuse, and membrane separation technology. His current research line is related to modification of polymeric membranes for application in water and effluent treatment and ceramic membranes for the separation of methane and carbon dioxide. Professor Bieser has a collaboration with the Harvard School of Engineering and Applied Science. Please, Professor Bieser.
Thank you very much, Rita. I would like to greet to everyone. Good morning. I will share my presentation with you. Please, Rita, just tell me, can you see my presentation? Rita, can you see my presentation
Yes.
now?
Yes.
Yes.
Thank you very much. Okay, so as Professor Reinaldo mentioned, a very important issue that we have now around the world and mainly here in Brazil, in the metropolitan region of São Paulo, is water scarcity. And one of which is one of the problems that we are focusing on our research. And now I will talk about the potable use as a strategy for coping with water scarcity in the world. Of course, I will give you some overview about the problems of water scarcity. As everyone knows, water is a very important material to develop our world and also to supply the demand for the people who needs water. And this is becoming a very challenging problem because of many things. Water the cities development with the increasing of water demand, and also the problems related to the change on water precipitation profile. So you can see here in this picture two situations. The largest one is the indication of drought in many countries in the world. You can see in Europe, Africa, and even South America and North America, that the drought is a severe problem that can limit the water use. And here in this small picture, you can see the points where water stress is a reality. It means that the people are suffering with water stress. And in Brazil, even if you have having a lot of water, maybe roughly 12% of the superficial water in the world is available in Brazil. However, the distribution of this water is not equal in our country, which is pretty much the same in many countries in the world. So the scarcity problem is a very big problem that should be dealt for moving or having solutions for these problems. And what are the options for coping with the water scarcity? Of course, the main strategy is water conservation. So water conservation is the main thing that people should think about. So improving the process efficiency and also developing new equipment that can save water. Of course, many industries in the world have developed a lot of hydraulic device that can use less water, and this is maybe the priority that should be applied. Even in industry, the process should be improved in order to reduce the water consumption. We had worked some time ago with this subject, developing new ways to use the water for industries, and we got a lot of good results. Even some process, the reduction of close to 60% of the water consumption, just improving the process developed at that industry. So water conservation, I think, is a very important tool that we can be used for coping with problems with water scarcity. And the second option is water reuse. Water reuse is discussed all around the world, mainly for some non-potable reuse or non-potable activities or non-potable use of the water, mainly for toilet flushing, irrigation, and cleaning of equipment, cars, and things like that. And more recently, people are also focusing on potable reuse. So what are the main drivers that can direct to one or other option for reuse, non-potable or potable reuse? That is the main focus of my presentation. The first one is what we should consider when we are trying to develop a non-potable reuse scheme. I think that the main issue is that we think if it's possible to implement a comprehensive water reuse scheme for non-potable use. And in that sense, we should also consider which sector or which economical sector we should prioritize. And of course, what is needed to implement a water reuse scheme. Of course, we need to talk about or think about the potential demand, which is the users, if the demand is concentrated or distributed. The reuse water quality standards that should be maybe obtained for the treatment. And in this sense, depending on the quality standards, you need to improve or to implement the correct technologies for obtaining such quality. And I think one of the biggest issues related to non-potable use is the distribution system. Because if you want to implement a comprehensive water use scheme, you need to have the distribution system. And this system is, or this part of the system is the most expensive systems that we have. Maybe if you consider the distribution of drinking water, maybe the distribution system in complex regions like metropolitan regions, the cost could represent 8% of the total cost for the production of drinking water. I mean, treatment and distribution. Only the distribution represents almost 8% of the total cost. And then this is a very important issue. And when we consider different conditions, maybe in metropolitan regions, you can see here some metropolitan regions. In the up left, you have the São Paulo metropolitan region. And the right, you have the Berlin in Germany, and also in Los Angeles, California. You see a very urbanized areas where the distribution or the consumption of non-potable water is very widespread. So to implement a system for water use, in this case, non-potable use, you need to have a secondary line for distribution this water, which will cost a lot of money. In that sense, we also need to think the other possibility. I mean, the potable reuse. So the non-potable reuse have some limiting factors, like the demands are most distributed, high costs to implement the distribution system, treated effluent quality issues, because there is a lack of legislation to drive or to establish the quality parameters for reuse water, and of course the technological innovation that should be implemented in many countries. So these are, of course, non-potable use can be applied for some case. We have here in Brazil and also around the world, there's a lot of examples of non-potable use schemes, but this type of reuse scheme is very limited considering the demand of water for these concentrated urban regions. So in that sense, we have in another way factors that can motivate or can move into potable use. So non-potable use can cost a lot. It's of course the money that would be expended for implementation of distribution system. It's possible to implement new technologies for assuring the quality of water for potable consumption. The use of such technologies make possible to implement a planned reuse scheme, and what is happening in many countries around the world. It started maybe in Africa in the 60s, last century, and it widespread around the world. Mainly, we have nowadays many countries around the world that implemented potable use scheme for coping with the water scarcity problems. So here we have two news about this. So Texas lead the way with the first direct potable use facility in the United States. And we know that the United States is very stringent, have a very stringent legislation about the environmental issues and also for the safety of the people who will consume the water. So they had authorized this kind of water use scheme. And also we have other areas around the world that can make or are turning wastewater into drinking water. Mainly during the last dry season that we have, like in 2014, 2016, in Australia, Brazil, South Africa, and so on. So this is a process that can be used for reducing the problems associated with the water scarcity. So what are the options that we have for potable use scheme? Basically, there are two options. The first one is the undirected potable use. In the case that you use a reservoir as an environmental buffer, just to characterize the wastewater, the treated wastewater. And of course, we have the direct potable use. The direct potable use is divided in many other subclasses. So you can just inject the treated wastewater in the raw water pipe that will supply the treatment plant, or even in the treatment plant, in the pipe of the treated water, and of course in the distribution system. Which one is the best option? Of course, it depends if in the place we have a reservoir close to the wastewater treatment plant to just deliver the reused water, and of course in many regions that you don't have the reservoir to work as a buffer, the options would be the direct injection of the reused water into the distribution system. So each one has advantages and disadvantages, which should be considered case by case in each country or each regions that have problems with water scarcity. Here we have some examples of water reuse, potable reuse, direct and indirect. As I mentioned, the first one is from the beginning of the 60s, last century. And also you have one which is the most commented, which is the Windhoek in Namibia, who direct reuse water since 1969. This system was updated in 2002 to include new technologies, but If you can see here in this table, in the next table, most of the process treatment or the arrangements for production of water use, mainly direct or indirect potable use, is membrane technology, considering microfiltration, reverse osmosis, advanced oxidation process, and of course the final chlorination. This is the scheme that has been established for producing safe water or safe potable use water. Other examples you see here is from 2016, and nowadays we have a lot of new projects being implemented for coping with the problems of water scarcity in these world. Since this process have been succeeded well along the time, the World Health Organization decided to publish a guideline to orient many countries or regions that want to implement water reuse or potable reuse schemes. So, but for implementation of potable reuse schemes, you have some incentives associated to the quality of produced water by treatment structures. Of course, many contaminants that are not regulated by the current legislation, and of course, the need for the development of a specific regulation for potable use in each country. So this is, I think, the most important issue that should be overcome by the countries that want to implement this kind of options for coping with water scarcity. So, of course, potable use have a lot of factors that are favorable to it. So the increasing of water scarcity problems around the world, risks associated to unplanned potable use. The potable use already occurs in many countries because in many cities just catch the water from the reservoir, use the water, treat this water, and then release the water to a water body that is used for any other city for producing drinking water. This is, of course, a way of potable use, but it's not planned. And of course, there's a lot of risks associated with it. And finally, we have also well-succeeded potable use examples all around the world. And finally, the development of international guidelines by the World Health Organization, which occurred in 2017. So now, most of the countries that want to move for potable use can just use the guidelines published by the World Health Organization, which is the same entity that publishes the guidelines for potable water or drinking water that is adopted in many countries around the world, even Brazil, by the health ministry. And this is a very good source that people can use to planning a way to reduce the water scarce potential in the region using potable use option. Of course, there are some key messages for implementing potable use. Of course, I will not read all of them, but one of the most important is that the potable use represent a realistic, practical, and relatively climate-independent source for drinking water, because independent of the climate, you have water. People will use water. Of course, you have sewage to treat, and of course, produce drinking water. There is another issue related to the complexity of the system to produce the water with the quality necessary for potable use, and a need for a framework for controlling this structure for producing water reuse. It's not a easy task, but is a possible task to be adopted for many countries that are facing water scarcity problems. One of the things that the WHO requires is the use of water safety plans, which is a very specific strategy to control the quality of the water that will be provided to or for the population. And this water safety plan is based on the multiple barrier concept, which means that to implement a lot of strategies for controlling the quality of water to be supplied for the population. It means related to the water source, I mean the quality of the sewage that can be used for producing drinking water. We should prioritize the use of domestic sewage, the implementation of water quality standards, the implementation of technologies for the treatment of this kind of water source to produce drinking water, and of course all the needs for monitoring and to control the collection of the final wastewater that will be produced. And here is some other key messages from the WHO for implementing water reuse schemes, which is the main or the most important is the presence of enteric pathogens that presents high risks for potable reuse schemes, and of course the contaminants or the emergent contaminants like pharmaceuticals and personal care products that should be present in nanograms or micrograms per liter. So the structure for implementing the water reuse schemes should be all devised in order to assure that the water that we provide by to the population is adequate for potable consumption. So in that sense, we have these key elements. So reuse water source, prioritize the use of domestic and commercial wastewater, assure the use of adequate wastewater treatment technologies, use of additional treatment technology for assuring the removal of specific contaminants, the establishment of an adequate monitoring program, to adopt effective incident management and communication programs, and of course, independent regulation and control. This system should be regulated by different organizations than the ones that produce the potable reused water. And in the sense of technology treatment, we have here a basic scheme for establishing the barriers to remove specific class of contaminants. So you have dissolved organic and inorganic substance, dissolved organic, suspended solid, microorganisms. So you can use the traditional wastewater treatment, secondary biological, associated with micro or ultrafiltration, or even MBR system, reverse osmosis, advanced oxidation process, and of course the chemical adjustment. This is the basic scheme that has been applied in many countries for the implementation of potable use, being direct or indirect. And here, this picture shows just some examples of regions that had been implemented potable use scheme or have been studied potable use strategies, and I will focus here, of course, in Brazil. So I'll have two examples for reuse studies, one for indirect potable use and another one for direct potable use. And then one, I'm almost finished my presentation. I present the study that we developed for the Sanasa company, which is a sanitation company in the Campinas city here in São Paulo. And it is a demonstration process for direct potable use scheme. So Sanasa has a wastewater treatment plant based on MBR technology, where you can see here a picture of the system. So you have the pre-treatment of the sewage, and then the treatment, which is composed by an oxygen reactor, the biological reactor, and the membrane tank. That's the treatment, the sewage treatment. And we developed a study here at USP to evaluate different treatment arrangements for potable water production at this sewage treatment plant. Here is a flow chart of our pilot plant study, which we developed a way to test 5 different technologies for independently or combined each one. So we have the sewage from the treated sewage for the MBR comes to this pilot plant and can pass through a reverse osmosis system, an advanced oxidation process, activated carbon absorption, and we have tried also the biological activated carbon. Here's the picture of the pilot plant. This pilot plant operated by 1 year almost. And here we have the results for the best configuration that we reached. So in our study, even the treated sewage from the MBR system is almost adequate according to the Brazilian legislation for potable water. All the parameters from the sewage is in accordance to this legislation. The only 2 parameters that are not in agreement is the heterotrophic bacteria and apparent color. Most of the other constituents are in accordance with the Brazilian legislation for potable water. And of course, the treated water, based on this best configuration, address all the parameters. We also evaluated the estrogenic and androgenic tests for the treated water, and none of the samples presented indication of estrogenic effect or androgenic effect. But this system that we used was the only one that did not present chemical toxicity for the final water after chlorination. Most of the other arrangements that we tested presented chemical toxicity for the final water quality. So the best configuration, as it has been used around the world, is reverse osmosis oxidation, UV peroxide oxidation, and final chlorination. And my final considerations regarding this subject, there are many well-succeeded potable use experiments around the world or experience. And of course, countries that are facing water scarcity problem can consider this option to minimize water stress effects in their regions. And the technological development can assure the production of safe drinking water using treated wastewater. But of course, it's necessary to amplify the discussion about the potential of potable use for coping with the water scarcity in specific regions. So that's my presentation. Thank you very much for the audience. And Rita, it's up to you.
Thank you, Professor Miesa. And now the next speaker, Dr. Nevin Duich. Dr. Nevaduic is professor of the Department of Energy, Power Engineering and Environment of the Faculty of Mechanical Engineering and Naval Architecture in the University of Zagreb. He is the president of the management board of the Center for Sustainable Development of Energy, Water and Environment Systems, SDEWES Center. Professor Duic is also member of the presidency of the Adria section of the Confucian Institute and president of the International Council of the Academies of Engineering and Technological Sciences. Please, Professor.
Thank you very much, Rita, for this kind introduction. I'm very glad to be here and that we managed to organize this conference, and I'm very much sorry that I'm not in Sao Paulo now. It would be great to be together on site live, but it seems that the situation, post-COVID situation, it's quite complicated. Still, so we have to continue working online, and that will not reduce the quality of our scientific achievements. You're, I guess, all aware of the situation which is ongoing in Europe. We have a first or maybe second big war after the Second World War in Europe. And that one is also very much connected with energy situation, since most of European energy is coming from Russia. In 21, 40% of its gas was imported from Russia, 27% of oil, 46% of coal, and also nuclear fuel is coming mainly from Russia. Around 20% of uranium is coming from Russia, plus 19% of it coming from Kazakhstan through Russia. So we are very much dependent on Russia, and since we are supporting Ukraine strongly in this war, we have started a regime of sanctions against Russia. Coal and oil will be phased out by the end of the year. Gas is more complicated. We don't think we can really quickly phase out Russian gas, but there is a very big chance that Russia will try to instigate riots in Europe by closing down supply of gas. So the question is what Europe can do in this difficult situation. It's clearly not a situation that we were not aware of. Security of energy supply would tell us that we should not import all the fuel from one source, that we should not import more than manageable and easily replaceable part of fuel from one country. But on the other hand, Russian gas was much cheaper than other gas sources. So we were happy to develop this dependence. What can we do about it now? If we look at our dependence, we can see that on the left side is how much oil each of the European Union country is importing. We can see these are quite big quantities. And on the right side, it's the share of consumption of oil. We can see Europe doesn't have significant own production of oil, and Russia is relatively close. Other sources of oil are quite far away. So it was logical to import quite a lot of oil from Russia. The fortunate thing about oil is that only a relatively small part is coming by pipelines, which are difficult to replace. We have enough infrastructure to receive oil by sea. So oil will be relatively easy to replace by the end of the year. The problem of gas supply vulnerability is much higher. The red countries are the ones that don't have enough of storage, and also they depend significantly on gas imports. So this is where we can expect that problems will appear potentially the next winter. Some of these countries like Finland and Estonia have already stopped importing Russian gas. Finland is not very much dependent on gas at all, so they will probably manage to replace it by LNG imports. But some of the countries in Central Europe may be quite in difficult situation. If we think how shall we replace around 150 billion cubic meters of gas imports from Russia, we can replace around 50 billion cubic meters by increased LNG imports. So that's 1/3. Then we can increase pipeline imports by 10 billion. We can switch on coal power plants to replace some of the gas power plants. With that way, we can replace around 22 billion. We could not close down some of the nuclear power plants. Belgium and Switzerland have already decided to extend for a few more years all nuclear power plants that should have been shut down. And Germany is pondering would they close down the last 3. But as we can see, this is only a very small part. It's only 12 billion cubic meters. Then we can switch to oil and oil derivatives using them in gas units. It's only 6. We could increase a bit production in nuclear power plants, which are now quite a lot in downtimes, but that's also quite a small one. So we can also switch to renewables more quickly. The problem with renewables is that you cannot really switch very quickly to them because there is need to prepare projects, to build projects, and only then they provide replacement energy. Around 9 billion cubic meters could be replaced by biomass and biogas, increased use of biogas and biomass. Then increased and accelerated development of wind and solar energy could save us another 5 billion. Switch to heat pumps 1.5, solar panels on roofs 2.5. Increased production of biomethane 1.5. And then we have to go into some savings. We will have to reduce temperature in our homes for 1 to 2 degrees, and 1 degree can give us around 14 billion cubic meters. We could also reduce air conditioning in summertime, and there is also a movement not to cool down under 25 degrees. So 25 degrees, it's feasible to stay, and this can save quite a lot of energy. And we are still going to be missing 13.5 billion cubic meters, which cannot be replaced next winter. So this loss will be probably handled by industry, which will reduce production, which means that we will have, of course, decreased industrial production in Europe next winter if we have a complete close of Russian gas. So to show it in a more simplified way what the EU thinks we can do. We switch to more LNG. This is Repower EU program. We switch to more pipeline gas, renewables, energy savings, some other ways, and without any savings, reduction of temperature, we can reach up, replace around 2/3 of Russian gas. 1/3 should be done with reduction of temperature in our homes and reduction of production. So we already have very very strong program for reducing greenhouse gas emissions in Europe. We are planning to reduce them by 55% by 2030. Currently, we are planning to reach 40% of renewables in gross final demand by 2030. But the proposal of European Commission is to increase that to 45%, which is now considered very feasible. Already, we have decided to ban sales of new internal combustion engine cars by 2035. We're completely giving up on this technology, moving very quickly to electric cars, which last year made more around 20% of the market of new cars. Also, there is a proposal from European Commission to ban sales of gas boilers by 2029. They're already forbidden, de facto forbidden in as a main source of heating for new buildings since 2020. European Commission is pondering on solar roof obligation, and it has decided to finance 40 gigawatt of electrolyzers by 2030. So we can see that EU is doing very fast transition in the next 10 years, but the crucial next two winters will give us certain issues. So experts have calculated that we can probably manage to get rid of Russian gas completely by 25 by implementing the measures already planned in Fit for 55, and then additional measures like efficiency measures, switching quickly to heat pumps and electrification of heating, switching to renewable electricity, and further increasing non-Russian gas imports via existing infrastructure. We can see that this transition will actually not be so expensive. These are the pre-crisis prices in US, so this is not European case. In Europe, natural gas was more expensive, natural gas, electricity before the crisis. Now it's much more expensive, even more expensive than nuclear. Even coal is now more expensive than nuclear, but wind and solar continue to be cheapest sources of electricity. So it completely makes sense to switch very quickly towards wind and solar energy for producing of electricity. But that brings us some problems because wind and solar are variable or intermittent. How we can solve that? Well, we can build more grid interconnection. Europe is relatively well connected, but we should probably double these connections in order to use the fact that wind is always blowing somewhere. but it may be in different times. So it will blow strongly on the North Sea when it will be very peaceful in the Mediterranean, and vice versa. So we need to build more interconnections. Actually, we could think of technically a world in which we would be running only on solar energy. Then we would need very strong intercontinental interconnections. Let's say 1,000 gigawatt between Europe and America, Asia and America. Well, this would be the cheapest way to supply all our energy needs. But the problem with that approach is that this is not geopolitically feasible at the moment. Who wants to depend fully on the energy coming from some other continent without possibility to store it for at least some months? And electricity is expensive to store. So we think that the grids, the continental grids will develop in the next 10, 20 years between the countries which have a relatively compatible political system, so they can trust each other. Smaller countries which don't have trustable neighbors will be in a more difficult situation because other ways of integrating variable renewables are more expensive. They're possible, but they're more expensive. We will need flexible thermal power plants during some transitional period because currently variable renewables are something that we can balance in the cheapest way using existing thermal power plants. We don't need to build any more thermal power plants, but we can use the existing one to balance wind and solar. We need to couple wholesale markets of electricity between different countries in order to, in these continental grids, in order to make that as cheap as possible, to remove barriers. And the crucial next step in developing energy transition is to develop demand response by integration of power, heating, cooling, transport, and water systems in so-called power to X. This is quite a big challenge for all of us, but for Europe, it seems we will be learning on fly very quickly because we are currently very much under pressure. Dedicated electricity storage is expensive. It's possible, but it should be used as last resort. So if we look at this intermittency issue, yes, wind is intermittent. This is last 4 years of real wind data from Europe. But we can see it's never zero because it always blows somewhere at the continent. So that means if we actually build enough wind so that we can cover the electricity demand with this baseload level or the red line level of wind, then wind can actually satisfy all our electricity needs. And the question is, how can we economically use the excess of wind above the red line? So in 20th century energy systems, they were working in the following way. You turn on the light somewhere and there is a power plant that will increase production to cover increased demand. So supply was following demand. In 21st century energy systems, we will have to turn that around. Demand has to follow supply because supply is something that is variable and that depends on meteorological conditions. For that, we need to have smart energy systems that allow for using electricity when we have it and not when we want it. Of course, everyone wants to watch TV championship game when it's happening. So there are certain types of demand which are time critical, but there are many other types of demand which are not time critical, like charging your car batteries or heating or cooling your house or office. There are also some things which we cannot electrify easily. We are thinking about road freights, trucks. They might go on electricity if we electrify roads. Short distance delivery trucks will for sure go on batteries. Longer distance trucks, if they're electrified on batteries, they will have to stop relatively often because of low density of energy density of batteries. There are other options for trucks: hydrogen, electric DME, which could be used in diesel engines, or electric LNG, which could be used in some engines, and then we could also think of ammonia and several other technologies. We don't know yet which way Europe will go with trucks. Shipping and aviation cannot be fully electrified because energy density is not high enough for intercontinental flights. But we could expect that short distance flights and shipping will be electrified. Europe has started moving long distance shipping and aviation into new fuels. Aviation will go into the mixture of sustainable aviation fuels, which will be produced from waste biofuels. So not first generation, but second generation biofuels, and more renewable hydrogen will be used in order to produce jet fuel quality of such fuels. For shipping, there are several lines developing. Most probably it will be ammonia as a carrier for hydrogen, which will be used in long distance shipping. But we're also open for electric LNG and electric DME as possible fuels for future. And there are obligations that by 2030, some small amount of fuels used in international shipping and aviation are these renewable fuels. Also, high temperature processes in industry sometimes cannot be electrified, and the best solution for them will probably be hydrogen produced on spot from excess wind and solar electricity. Why hydrogen? Well, because we can do everything on a spot. We don't have to build hydrogen infrastructure as we should build it for transport, which seems to be quite a difficult task. So for industry, in industries in which we don't need carbon fuels, we can use hydrogen. In industries where we will be needing carbon fuels or feedstocks, in that case, we will probably need some kind of carbon fuel based on carbon capture and utilization. Also, we will need backup for possible winter windless weeks. That might happen. I have shown that in last 4 years they didn't happen on European continent, but they still could happen. and we have to have backup for such situations. And possibly hydrogen, if we manage to store it seasonally, might play that role, or if not, it might be e-methane. That all makes around 20% of energy demand. So all these hard to decarbonize sectors. Biomass in Europe can sustainably be used for approximately half of that. In some other countries and areas, there is more sustainable biomass, but Europe is extremely densely populated, so we see around 10% of energy demand can be sustainably satisfied from biomass. The rest will be covered by synthetic or e-fuels, including hydrogen, ammonia, e-LNG, e-DME, e-methane, e-methanol, etc. Let's imagine that we build much more wind and solar than we actually need. This is a curve from previous year of actual wind and solar production on daily basis, and it is increased several times over the demand. The red line is legacy electricity demand. To show that we can actually build enough wind and solar in order to cover all our legacy electricity demand. But then we have probably around 2/3 of wind and solar electricity which are excess to what we need in the power system. What can we do with this excess of electricity? Well, we could electrify transport. This is already happening. We could electrify heating. Heating is quite a significant demand in Europe. Around 40% of final energy demand is used for heating. So we can valorize wind and solar in this way. And then we are going to stay with still 1/3 of electricity, which will be excess, and we can convert it to hydrogen. And we can use this hydrogen for industry and for production of synthetic or e-fuels for heavy transport. In this way, Europe can, by 2050, or hopefully even faster, manage to fully switch to wind and solar. Of course, we will not do that because we have quite a lot of hydro, geothermal, biomass, and all possible new energy sources. We will probably stick to some nuclear, which is of course clean, but a bit expensive. So in that mix of energy sources, Europe can become reasonably independent, but the problem is space. And some countries which are really densely populated and have quite a lot of industrial production and therefore quite high energy needs, might have a space issue with wind and solar. That's why we are also thinking about possibility of importing part of the hydrogen from countries where hydrogen is cheaper to produce. Of course, we don't want to be dependent 40% from one country anymore. I hope we learned the lesson, but there are much more countries which can produce cheap hydrogen than countries that can produce cheap oil and gas. If we look at wind share in electricity demand already achieved in 2020, we can see that some Brazilian states are really at the top of the world. They're not independent states, of course. So, so one can say it's not the same thing, but Rio Grande do Norte is as big as my country, Croatia. and it has 300% of wind energy in its energy demand, electricity demand. So it's a huge success. And then the question is, what is Rio Grande do Norte doing with its excess of wind? It's exporting it to neighboring states, which is great. The hydro potential in Brazil, it's having its problems lately on one side. On the other side, demand in Brazil is growing because it's still getting richer. So there is need for more electricity. But Nordeste is very rich in wind potential, and I'm sure that other states will develop this export capacity. There is no need for heating in Nordeste because it's, well, it's an equatorial climate. They need some cooling, yes, quite a lot of cooling, but no heating. So where they can use the excess wind? Electric cars are not very popular in Brazil because you have alcohol, which is a very important economical part of Brazilian industrial sector. So why not hydrogen? Hydrogen is a potential to decarbonize industry quickly on one side. On the other side, it could become a significant export fuel from Brazil. We can see that there is now quite a lot of, yes, one more thing. The picture behind me, this, what you see, it's Rio Grande do Norte. It's one of the wind farms on a beautiful coast of Rio Grande do Norte. If we look at all these countries and states which are above the green line, this is significant because up to 20% of wind, it's relatively easy to integrate with conventional energy system methods. But anything above the 20%, one needs to either develop storage, demand response, or interconnections, significant interconnections. Rio Grande do Norte has is using, for example, grid interconnections, but Denmark is using a lot of demand response with power to heat, for example. So we are going to be seeing a lot of growth in these percentages in the next 10 years. And then we will be also seeing quite a lot of difficulties in integration of wind. We can also see other Latin American countries like Uruguay is the leading Latin American country with 44% of wind share. We can see also Nicaragua is doing very good, so a relatively poor country. Brazil, the whole Brazil is 9%, which is quite good, but it could be much better. Honduras, 9%, Chile, 7%, Jamaica, 7%. Then we have Argentina, Mexico, and Panama, 6%. So Latin America is doing, I would say, quite well on the wind front. Let us see with the solar front. We can say that it's easy to integrate up to 10% of solar energy. Above the 10%, we are reaching some situation which is usually called duck curve, meaning that during the summer day, we cannot integrate all of solar energy into the power system. So we have to develop some kind of demand response. We can either store this energy into the cooling system, we can charge electric cars, or we can produce hydrogen. And we can see that some very poor countries are actually leaders, like Honduras and Yemen. On the other hand, we have already 100% solar country, which is a very small island state, Tokelau. small 3 islands. So solar battery systems are coming. We'll be seeing more of that. California with 16% as a large state with quite a lot of demand. It's currently at its limits because it didn't really invest that much into demand response. But I think they will start now because otherwise they will feel the problems. Unfortunately, Brazil, which has a lot of solar potential, is not really very good here. And generally, apart from Chile, which is 9%, Latin America is not really using its solar potential. And as we have seen from the curve from the beginning, solar energy is now the cheapest electricity what you can have. A few more words about options for heating. In Europe, there is a strong push to use hydrogen for heating, but does it make sense? So if we use electricity directly for heating and cooling with heat pumps or with COP3, then to cover 5 petawatt hours of heating demand in Europe, we need 1.6 petawatt hours of electricity. We are currently producing, well, in 2015, 2.5 petawatt hours. But if we produce hydrogen and then we use that hydrogen in gas boilers, we need around 9 petawatt hours, so around 6 times more. If we produce e-methane and use it for gas boilers, we need 10 times more primary electricity. It doesn't really make sense, whatever the gas lobby says. Also, when we look at transport, if we use electricity directly in electric cars, we need around 4.5 petawatt hours to fully cover electricity demand of transport. If we go through hydrogen, we need double that. So efficiencies are not that bad here as with heating. And if we go through some kind of e-fuel, we need 24 petawatt hour or some like 6 times more than electricity. So it's obviously the best to use electricity if we can, but due to the problem of energy density of batteries, which is still rather low, we will probably need some amount of some kind of fuels in future to power the heavy transport and the long distance transport. With this, I would like to thank you very much for this introductory address. I hope I have raised some questions. You can see that in Europe we are in a very difficult situation. We have to solve problems which we didn't solve for a long time, now very quickly. And I hope we will be discussing some of these issues at the third Latin American SDEWES in Sao Paulo. And I also invite you to think about the next 2 conferences, SDEWES conferences, which will be happening this and next year. Thank you.
Thank you, Dr. Nevin. And thank you very much to all speakers for these addressing lectures, Professor Júlio Meneghini, Professor José Carlos Mierzwa, and Professor Nevin Dwight, for the very interesting, informative, and relevant presentations. All the talks were particularly appropriate for this challenging time we have faced concerning greenhouse gas emissions, water conservation, and energy transition. We really appreciate the time all of you took for being with us and sharing your experience. Many thanks from all of us. And now we are passed for the next talk. It's a Marco Ban with some technical information for us. Marco Ban, please.
Thank you, Rita. So hello, everybody. Welcome to the third conference, Latin American Conference on Sustainable Development. Sadly, we have to organize it this way since, well, the situation was what it was. Since there is some time, I will just quickly explain why we do it like we do it, and talk something about the rules of the online conference. So basically, since the whole COVID situation started a couple of years ago, we also changed our way of organizing conferences to go fully online. And we had a couple of conferences to iterate through and find out the best model for everything. Well, the one question is why we don't do it fully online with Zoom. Well, we tried it in one conference. It wasn't fully online on Zoom. Some parallel sessions, regular and special sessions were held through Zoom, and it proved to be pretty exhausting both for speakers and for attendees, because we had a couple of hours in succession on Zoom, and we saw that people were quickly losing focus, and we also felt like a Zoom exhaustion, and we basically find out that this mode of having some events held live through Zoom and the rest as an online platform proved to be the winning combination, because first you have an option to watch every single presentation on the conference, which is like an added value. It's one of the, well, I would say not many advantages of having an online conference. So you can basically watch every single presentation that was submitted to the conference. I just before we had this opening, I just went through all the videos that were sent by authors. So we have like 20 hours of presentations to watch. So if you divide it by the three days that the conference will be officially open, there's well, a lot of it's almost like you're on a live conference in person. So there's a lot of material to watch, and unfortunately, what we are missing is the social aspect of the conference, the small talks between the sessions, and this is basically the huge downside of having the conference running this way. As for the rules for this conference, let me just share the presentation, the slide for this. As I saw, most of you are already starting to watch the videos on our online platform. You all received a link, an invitation, a basic set of rules, a document with instructions on how it works. It is quite straightforward. Anyone who has watched the YouTube videos before knows basically what's it all about. The papers are divided into sessions by their topic. You can watch papers or presentations in your own pace. You can binge watch it for consecutive 10 hours, or you can watch it with breaks. What is important here is that there is a limit to the timing of when the watching will be available. So we will keep the videos available for watching until Thursday. So until the It will be past the closing session on Thursday, so until midnight, Brazilian time, until when you will also be able to ask the authors questions through the comment section below each video. As I said, unfortunately, this social aspect of the conference is something that is difficult to really create in this way. So the only way to make it work is for the participants to engage as much as possible by asking questions to other participants using comments, and also the participants are required to respond to any question. So you can also post a comment, so it doesn't have to be a question, but the questions are what basically counts. And to give a small incentive to this part, so is some of the most active participants will receive a certificate for their activity and basically their contribution to the conference. Of course, every day I will send the links to the Zoom, so we don't clutter up the inboxes. I will send every day an email with the information on how to connect for the live event for the next day. So in a couple of hours, you will receive the links for for tomorrow's invited lecture and the panel. And also, I will send periodical notifications to authors who did not respond to the questions. Know that in some cases, I mean, it's all done automatically. So in some cases, it doesn't. It might not be a question. It might be some comment that you don't need to be reminded of. So be patient, and I'm sorry up in front for it. And also the links for the live events are also available in the comment system as when you log in. So 5 minutes, I think, before the event starts, the link will be there. If you forgot to delete the email with the information, and that's pretty much it. I mean, I can also only invite you to be active, to engage, to watch the presentations, to ask questions. There are some questions already online. I can only say that not many Brazilian participants are asking questions, so the local guys should also jump in and make it more lively. And also for the Zoom sessions, I mean, unfortunately, well, most of us are quite familiar with Zoom in the past couple of years. So all the events will have an option to engage through chat, Q&A. We will not have Zoom live sessions conducted through as a meeting. It will all be webinars. So use the chat option and also Q&A. And also, as I wanted to say, also one of the benefits for asking questions, what we experienced in the past period when we are holding this the conferences this way, is that the quality of questions is immeasurable compared to the live on-site events, because participants or viewers have more time to formulate the question, and authors also have more time to think about of a quality answer, and we could see that the discussion is really of a higher quality than what you would experience in an on-site event with a 5-minute discussion available after each presentation. So use this opportunity to learn more, to ask questions, and also to answer them. And also for the real time, since we are in numerous time zones, you can check the schedule webpage on the conference to see when the specific event starts. I try to make it the time zone conversion automatical, so the default times are Brazilian or Brasilia Standard Time. But I try to use the option to convert it to your browser time. So if you are in doubt, I will also send a link to the time zone converter, also which you can use to check when is the exact time for the certain event. And the last and almost the most important part are the publishing rules. So those who have submitted their work as an archival submission. When we have the on-site event, one of the major prerequisites for being invited or being in the process of being invited to a journal special issue is that the work is presented at the conference. Since we are not obviously on site, the main rule for being eligible for the special issue selection process is that you have first, which almost all of you did, is to upload or send me your video presentation. And the second one is to be active and to answer any of the questions by the authors. Those who fail to answer questions will just not be eligible. Their paper might be included in the journal conference proceedings, but they will not be eligible for a special issue selection process. So keep it in mind. Every time somebody posts a comment to your presentation, you will receive a notification email with a link, direct link to the specific comment, which you can click and then answer through the platform. So this is the only way we can track that you have addressed the question in an appropriate manner, and which pretty much I would say is not the hardest part on your side is done. So you have created the presentation, you have uploaded it, it's on the platform. So now all you need to do is be polite and answer the question you have been asked. Also, I will periodically send reminders to those who have not answered the questions for, I don't know, 12 hours or so, just to remind you, because sometimes, okay, the emails end up in spam folders, and you can also check the log into the platform. If you have some pending issue, you have a small bell in the header to remind you on this, so that there is no way that you can miss anything that is required from you. Also, come back to the closing session when Professor Dujic will have more information on the post-conference situation with the special issues. I think that's it from now. For now, from me, I think we are making good time and good progress. So I will return the word back to Rita for the next event.
Thank you, Marco. I think you have a little bit time. It's good to have a break and come back at 11 with Professor Paulo Artaxo lecture.
So we have 5-minute break if
Yes.
somebody needs to.
We don't have coffee break, but it's time to drink the water.
It's standard, yeah. And then we return for the invited lecture.
Yes. Thank you, everybody. See you later.
Hello, Paulo. Can you hear us?
Oh, yes.
Okay.
The sound is good also for you?
Yes, it's excellent.
Okay. Just ready. Video, everything okay. Internet with good speed. That's perfect.
Yeah. I have the pleasure to introduce you, but your CV and your honorary awards are so long, the list I have skipped a bit.
Let me warn, limit the presentation to 30 seconds.
Yes, okay.
No, that's, I hate this kind of thing,
Yeah,
this kind of presentation that lasts for 1, 2, 3 minutes. 30 seconds. Professor of University of Sao Paulo, and that's it. And then let's go for what really matters.
A bit more, yes, but not everything.
Okay. Let me try to test my share screen just to make sure everything is okay. Yeah, you will see full screen, right?
Yes, now we see the full screen. Yeah, perfect.
Okay, good. Oh yeah. Okay.
Will we start?
That's the question. Should we start exactly at 11?
At 11? Could be.
And let's hope that the people are back from the coffee break.
Or the water break.
Or the water break, yeah.
It's 11.
Yeah, it's always a bit a problem in Zoom when all the people have their black tiles, so you don't know whether they are really
Yes, we
here.
don't know.
But I would like to welcome the audience to our first invited lecture. And my name is Ingo Stadler from TH Köln in Germany. I have the pleasure to introduce our invited lecture. I myself, I'm a bit disappointed that we are meeting here online and not in Sao Paulo itself. I love Brazil. I'm so often there because I organize our university collaborations with Brazil. Most often I'm in the Northeast in Fortaleza, but also regularly in Rio de Janeiro, or recently we started with the hydrogen boom, also cooperation with University of Santa Catarina. Unfortunately, I never had been at USP so far.
We may invite you.
Yeah. I have the pleasure to introduce Professor Paulo Eduardo Artaxo Netto. He is graduated in physics by Universidade São Paulo, USP, in 1977. He holds a master in nuclear physics and a PhD in atmospheric physics, all two by USP. He worked for NASA in the United States, the universities of Antwerp in Belgium, Lund, Sweden, Harvard in the United States. Currently, he is professor at the Department of Applied Physics at the Institute of Physics at USP. He works with physics applied to environmental problems, working mainly on issues of global climate change, environment in the Amazon, physics of atmospheric aerosols, urban air pollution, and other topics. He is member of the Brazilian Academy of Science and the World Academy of Science. He has published hundreds of scientific papers and presented more than 1,000 papers at international conferences. He is also a member of the Intergovernmental Panel on Climate Change, IPCC, and of a lot of other international scientific panels. I don't want to mention all of them. So now I would like that we welcome Paulo Artaxo with his lecture, Climate Change and the Challenge of Regional and Global Sustainability. The screen is yours.
Thank you very much, Ingo. Hello to everybody. Good morning, good afternoon, depending on where you are. So I will start sharing my screen. Okay. So basically the idea is to discuss one of the major issues for humanity over the next decades. That is how to fight climate change and at the same time have a minimum of sustainability, not just on the climate, but also on the social and economic issue, as we're gonna discuss briefly. So basically, first to take a look on the recent past. So let's take a look a little bit of history. It's always important to remember that the Stockholm United Nations Conference on the Human Environment, that was the very first global conference dealing with the sustainability for our society, happened already 50 years ago. That was in 1972. The Rio 92 conference was already 30 years ago. The Rio plus 20 was 10 years ago. And then we had the 26th Conference of Parties from the climate agreement in 2021. On the right, you see, let me get my laser point here, you see basically the evolution of temperature since the start of the Industrial Revolution until today. So you can see very easily that basically what we see is that any of the COPs had no impact or no effect on reducing emission, or at least minimally mitigate the temperature increase. So basically we have now a planet that is 1.1 degrees hotter than before the Industrial Revolution, and some continental regions like Northeast Brazil or Amazonia is already 2.2 to 2.3 degrees higher temperature, and parts of the Arctic are already experiencing more than 2.5 degrees in increased temperature. So basically this is what we call the climate emergence that we all heard about over the last few years. The first thing that is also important to notice is that climate change science is very solid. On this slide, it's just a few of the recent reports on climate change, not just from the IPCC, but also from the UNEP, from the Biodiversity Commission, from everything, from food production and so on. So basically you see that recently the climate change science per se is very, very solid with a lot of work from the scientific community. And then the last IPCC report are really relevant because of the very clear message that science is telling to our societies and governments. The phrases like this: recent changes in the climate are widespread, rapid and intensified, and unprecedented in thousands of years. Look that, pay attention that our planet has 4.5 billion years of age, and humanity, Homo sapiens, appeared in our planet only in the last 200,000 years. And climate change, it's really intensified just 50 or 60 years ago. So this is a very, very, very recent phenomena that is changing the planet, that is unprecedented in thousands of years. And then IPCC sent a very clear message. Unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees will be impossible. So basically, you're going to learn over this presentation that actually our emission patterns today are bringing us to an average increase in temperature of 3.2 degrees in average, that in continental areas will increase the average temperature by about 4 to 4.5 degrees. This is where we're bringing humanity and the climate of the planet to an unprecedented level. And this is basically caused by emissions of greenhouse gases. So this is the global net anthropogenic emissions. So basically, we are emitting about 60 billion tons of greenhouse gases every single year to the atmosphere. And this, besides 50 years that science put clear message to governments and the society, the emissions are still increasing by 2 to 4% a year over the last 10 years. So basically, all Paris Agreement, all the Conference of Parties have an absolutely negligible effect so far for the reductions in emissions. And this increasing of emissions are bringing important changes in the climate. So on the plot here on the left is the temperature record of the last 2,000 years. So basically you see that the temperature was very, very stable over the last, let's say, 1,000, 1,500 years. And then recently we'll see this strong and very fast and rapid increase in temperature that is not, that had no history for at least 2,000 years. And actually, when you get the period of the climate system that were as hot as today, was at least 100,000 years. So this gives a dimension of how serious is the climate emergency we are getting into right now. And this small film showed the land temperature anomaly distribution from the 60 up to today, where you see that in 60 and 70, the average temperature was more or less close to zero, and then it starts to shift quickly to the right to a hotter planet until we could have in 2020 an average increase in the land ecosystems of about 1.6 degrees. So basically where humanity do most of his activities, actually you are experiencing an increasing above what the target for the Paris Agreement. And it's also important to see the increase in climate extremes here. You see that the fraction of the time where you have temperature larger than 2 degrees above the average or 4 degrees above the average have increased by more than 80%. And one of the results is, of course, the climate extreme events we are having with the heat wave over the United States, over Europe, and over Asia that we are experiencing over the last 3-4 weeks. And this is not news, new issues. For instance, in South America, the temperature anomaly shows that a significant part of Brazil and also Peru, north of Argentina, have already increased in terms of temperature more than 2.3 degrees, and shows that the planet is heating up very, very fast. And on the map on the right, you see the precipitation anomaly, showing that actually Brazil and South America is becoming much drier over the northern part of South America and a little bit wetter in the southern part of Brazil and northern part of Chile. So basically what we are seeing is very important changes in precipitation pattern as well as in temperature. And then humanity is very interested in to know where we are going to. Basically, what the climate modeling can tell us about the future of the temperature in our planet. So for that, you need to understand the relationship between emissions, concentrations, change. This brings concentrations, changes in concentration of greenhouse gases. This changes the radiative forcing of our planet. That is the fraction of the energy that the planet uses to keep life on Earth. And then this brings warming, and this brings the impacts we are observing. So basically, human activities directly are responsible for the changes in the atmospheric composition. This changes the energy balance of the planet, and then we have important impacts. And then to predict the future climate, IPCC have designed 5 different scenarios. One of them is the scenario as we are going to right now, keeping it emissions as we have right now. As I mentioned, we are emitting about 60 billion tons of greenhouse gases to the atmosphere. And then there are 2 different scenarios with the loose implementation of the Paris Agreement and 2 very aggressive scenarios of reducing emission and stabilizing the climate. For these 5 scenarios, we enter these in large supercomputers that try to model the complex climate in our planet that includes our society activities. And then the results are shown in this plot. Basically, if you don't do anything in terms of a reduction in temperature, we can bring the planet to a 4.4 degrees in heating in average. If you implement the Paris Agreement, first, in a very loose way, we can increase the temperature at 3.6 degrees or 2.8 degrees. And if you do a very strong actions immediately, as I'm going to discuss later in the presentation, we can limit the temperature to 1.8 degrees or 1.3 degrees. So basically, you see that these are the scenarios that the governments and our society are dealing with. Which is the future of climate that we want? Do we want to increase the temperature by 4.5 degrees in our planet? Or, and this will bring a lot of consequences like destruction of ecosystem, disruption of the food system, and so on. Or we want to go for minimum of the greenhouse gas emissions and then keep the climate with the minimum perturbation from human activities. These are the questions we have to deal with right now. And then, but more important than the average temperature for the whole planet that includes the ocean, it is important to analyze the geographical distribution of this increase in temperature. If you allow the planet to heat up by 4 degrees, basically Brazil and South America, we have an average increasing between 4.5 to 5 degrees. The Arctic, Canada, and Russia can have an increase in temperature of between 6.5 to 7 degrees, with very large impacts on the ecosystems. But in addition to the increase in temperature, we are also changing the precipitation pattern, where and how much rains in every piece, in every part of our planet. So you see that, for instance, if you allow the temperature to go to 4 degrees, we have South America, North South America, including Amazonia, a much drier region, as well as Southern Europe and Central America and South Africa. So basically, this is a process that is already happening, is not a future projection, because we are already observing these changes in precipitation. The changes in precipitation bring important changes in soil humidity that is critical for agriculture. So if you allow the planet to heat up by 4 degrees, looking for the soil humidity amount in South America, in Central America, and Central United States, it's important to note that, Nevada and California is already being observed much lower precipitation than, let's say, 30, 40 years ago. But also South Africa and the Mediterranean, Europe, and North of Africa will also observe a very significant reduction in soil humidity. And this is critical for food production. For example, here you have a more detailed map of the change in soil humidity. You see that no question about, we will have a severe change in the geopolitical issues, with the capacity of producing food very much compromised by climate change. And then this is not new. Brazil knows this quite a long time. This is a report from Embrapa, the Brazilian Agro Industry Research Institute. This is a report from 2019. So you see that, let's say, in the recent past, the regions with the high or very high water deficit was limited to the northeast part of Brazil. But now, this is being extended to Goiás, Mato Grosso, Tocantins states, and this is getting more intense this decade, and next decade we will see an important reduction in precipitation in the areas where agricultural production is very intense in the central part of Brazil. So this has important implications for what kind of economic development Brazil and other countries plan to have over the next decades. And this is also not new from the World Economic Forum. So basically, the World Economic Forum Global Risk Analysis from 2020 shows that the risk in the impacts of food production in a 3 degrees hotter planet is a reduction in the yield, in the productivity of food for South America, for most of Africa, Southeast Asia, and India. So you see that the tropical countries certainly will suffer most from the increase in temperature and decrease in precipitation, while countries like in Scandinavia, Russia, and Canada will have a possible increase in productivity in their agricultural systems. But basically, you see that most of the United States, Central America, and South America will suffer significantly from climate change. And then there is the issue that climate change is already affecting weather and climate extremes all over the world. So it's very, very significant changes in climate extremes identified by IPCC. So basically you see that last year we had 52 Celsius in California, we have 48 degrees in Canada, in Vancouver, and at the same time, we have the largest precipitation in the last century in Germany. We see drought in central Brazil, the largest flooding in Amazonia in 119 years. So basically, it's very, very clear that climate change is bringing more intense and more frequent climate extreme events. We are seeing this year, we are still going on with strong heat waving. For the first time, it's important to note this detail. We had previously heat waves in Europe, in United States, in Asia, but now we have a heat wave that simultaneously gets the three continents. And a temperature of 44, 43 degrees in Spain, in Portugal, in California. And then this is bringing a lot of fiery danger forecast for Europe, for California. You see Yosemite being half burned so far. So basically, this brings a lot of socioeconomic issues, including the loss of lives. And how climate extremes will change in the future. So IPCC addressed this issue, put the simulations included the simulations in the climate. So basically, one single event that happens every 50 years before global warming took over in a 4 degrees Celsius world, this event will be 39 times more frequent than, let's say, 100 years ago. So basically, this will happen, extreme events will happen almost every year if you allow the climate to go 4 degrees, and they will be 5 times more intense. So basically, this is a very clear message from science to this society about the climate extremes. Another important impact from climate change is the change in sea level. So basically, sea level is rising significantly over the last, let's say, 50 years. And the forecast for IPCC is that at current emissions, we could see increase in sea level, in average sea level rise by 1 meter if all high probability events are included, and if the low likelihood events are included, we can have an increase in sea level by 1.7 meters. So this is a huge change for all coastal areas, for all the planet. And of course, this is an average sea level rise. If you see that some parts of the world will have a much more significant increase in sea level, so this will impact millions or billions of people worldwide. But in addition to that, IPCC have also made simulations on how could be the global sea level in 2300. So basically 300 years from now. The important point is why IPCC have done that. By a simple reason. If you melt 1 cubic kilometer of ice from Greenland, and this water goes to the ocean, increasing sea level, there is no physical process that could revert this process. I mean, this is an irreversible change. And if we continue emissions of greenhouse gases, the global sea level rise could reach 15 meters by 2300, according to the simulations from IPCC. So again, it's a very, very clear message for the society to reduce immediately greenhouse gas emissions, as we're gonna see in the end. And another important message is that the proportion of CO2 emissions that are being taken by the land ecosystem and the ocean will be reduced significantly with the higher cumulative CO2 emissions. So basically right now, the atmosphere and the ocean are absorbing 70% of our emissions, and this could be reduced to 40% if we will continue emitting greenhouse gases that we're doing now. What this means? We will accelerate global warming very significantly. And then just a little bit discuss the relevance of Amazonia. That is an important tropical forest, and it's important to understand that Amazonia impacts very significantly global climate through deforestation and greenhouse gas emissions. But on the other side, climate change also impacts Amazonia very significant to forest degradation. That is a process that is already going on, so making Amazonia a source of carbon to the global atmosphere. This has been simulated by the climate models, and what happens is that when we analyze the carbon uptake, the photosynthetic response from ecosystem to climate warming, you see that Amazonia will become a net source of CO2 to the global atmosphere at a rate that could reach 1 kilogram of carbon for every square meter for every degree Celsius that will allow the climate to heat up. And this is important because Amazonia contains 120 gigatons of carbon in the ecosystem, and this is equivalent to about 10 years of fossil fuel emissions. That with the progressing of climate change, this carbon that is stored on the ecosystem right now and have been there for millions of years could start migrating to the atmosphere, aggravating the climate system. This is what we'll call the tipping point from the Amazon. And in addition to that, we have a very high deforestation rate in Amazonia, even right now, after Paris Agreement, after everything. So you see that Brazil shows that it's possible to reduce emissions from deforestation. Brazil have done it already. It is the cheapest, fastest, and easier way to reduce emissions is reducing tropical forest deforestation. But unfortunately, because of the actions of bad and irresponsible governments, what we are seeing is an increase in deforestation in Amazonia over the last 5 to 6 years. So basically, we have to zero this deforestation by 2028. So we are observing an increase by 21% for 1 single year alone. And the Global Carbon Project sending a clear message that achieving net zero by 2050 depending critically on the Earth's natural carbon sinks. So basically, we have to preserve the natural carbon sinks in the boreal forest, in the temperate forest, in the tropical forest, wetlands, and so on. So basically, science gives you all the ingredients of how to avoid the aggravation of the climate emergency. So science have done his job. So basically now the task is with our government, and which have been the actions of the government. So we can see the document from the COP26, the Glasgow Climate Pact, as we will call it, basically see a tremendous distance between science and the geopolitical interest, especially from the developed world. IPCC says clearly we needed to reduce emissions by 45% until 2030. That is only 80 years from now, but you are in the wrong direction. We are increasing emissions with all these warnings that science has made over the last 50 years. We are going to an average increase so far today with the old implementation from the Paris Agreement to about 3.2 Celsius instead of 1.5 Celsius, that is the target for the Paris Agreement. So basically, we saw in Glasgow an agreement to reduce methane emissions by 30% by 2030. So basically, there are some advancements in papers and in agreements, but very few results so far in, let's say, concrete terms. So basically, the net zero targets, net zero emission targets for most of the developed countries are for 2040, 2050. Some countries has a target for 2035, but ideally, this should be 2030. But basically, India has the target to become net zero only in 2070, China in 2060, Brazil in 2050. So we are very far from what science says that is absolutely necessary to stabilize the climate. And basically, there is an important difference in developed versus developing world, because in COP26, the poor countries of the world asked for help, financial help from the developed world to reduce their emissions that will profit everybody. So basically, they were claiming about 100 billion per year of help for the poor countries to adapt and reduce emissions. And what was the answer from the developed world? No, we will not provide these funds for the developing countries to reduce their emissions. We have to negotiate this at the next COP. In a scenario like this, possibly we will see much stronger heat waves as we are observing right now in Europe and United States and in the developing world. So basically, we see clearly a need to change the socio-economic system and the governance of the climate change and global problems. And just going to finish my presentation, I think IPCC sends a lot also on positive message on climate change. IPCC says clearly there are options available now in every sector that can at least halve the emissions by 2030. So the message is very clear. We have all the technology in all sectors to reduce emission by 50% in 2030. The message could not be more clear, and this includes the energy sector, the land use sector, industry, urban, buildings, transportation systems, and also on the service economic sector. So we don't need anything else than implementing what science tells what we have to do. And this is basically due to the fact that renewable energies prices has fallen below the burning of fossil fuel. We'll see the price from photovoltaics coming down from $600 per megawatt hour to about $70 per megawatt hour. So basically, you see that it's cheaper to produce electricity from photovoltaics than burning fossil fuel, especially now with the increase in prices in the oil prices. The same with the wind onshore and offshore wind generation. The prices are much, much lower than they were 10 or 20 years ago. And then there are options available to reduce emissions in all economic sectors, in special the energy sector, and the changes in what we call AFOLU, that is afforestation, florestation, and other land uses. So you see that we can significantly contribute to net emission reduction from these two sectors that could help a lot to stabilize the increase in temperature at the maximum 2 degrees. And in particular, the forest sector has the very low cost to implement this change, and wind and solar energy, the costs are lower than burning fossil fuel. So you see, it's possible. The message could not be more clear. And then what we have to discuss in terms of society and conference like yours, it's important to make this discussion widely, is that we are here, 2022, when IPCC released his 3 reports. And the question is, are you going in the future to a world where we have a lot of vulnerability, high poverty, we will have a very low resiliency to climate change, or we will adapt and stabilize the increase in temperature in 1.5 and 2 degrees. We keep the ecosystem health, the equity and justice in the very best point. So basically, we have to choose a pathway from now to the future. The pathway that the economic sector have chosen is this red one, very clearly, with emissions of about 60 gigatons of CO2 equivalent to the atmosphere every year. But certainly the interest of most of the population is actually to build up a sustainable world, because that is the only way we could guarantee a minimum of well-being for our society. And it's important also to analyze who actually is responsible for the emissions of greenhouse gases. What we see is that the 10% rich of the population emits 49% of the total greenhouse gases. The most vulnerable and the 50% poor of the population emits only 10%. So it's a clear message that our level of consumption, especially in the developed world, is completely unsustainable. And the problem is they are responsible for most of the emissions, but who will suffer most from the increase in temperature is not an American that lives in Texas in a 400 square meter home and have 3 cars in his garage, but actually is a poor guy in Bangladesh, in India, or in the favelas here in São Paulo or Rio de Janeiro. So there is an intrinsic link with the inequality that certainly is a very important part of this equation. So basically then for science, the question is how to build a safe and fair space for humanity. So how to combine the basic needs of the population: water, food, health, gender equality, social equity, energy, jobs, and so on, to the limits of our planet in terms of use of water, preserving biodiversity, and so on. So science, an interdisciplinary science in particular, have to build up the bridge, taking care of the safe and fair space for humanity. So this is a huge task that we scientists have to fulfill over the next few decades. And a very good guidance for science and also for governments are the United Nations 17 Sustainable Development Goals that put a pathway on how we are going to deal to build up a sustainable society with no poverty, with zero hunger, with good health and well-being for everybody, and so on. Climate change is the SDG 13, is the climate actions for a sustainable planet, but many others SDGs actually depend critically from the climate. So basically, this is a huge task that you have to change our economic system completely, actually, to fulfill and build up a sustainable society. So basically, it's very clear that the climatic and environmental issues will be increasing in relevance for our economic development and our social impacts, including jobs and socioeconomic inequalities. And I leave you with a possible picture of the new climate of the planet that we have to avoid as much as possible, but we are not being able to track, to guide the societies and governments to a sustainable society as is absolutely necessary. So basically, I stop sharing my screen right now, and I will be very happy to answer any questions you could have. Thank you for the attention.
Thank you very much for your interesting presentation, Paulo. You are free to ask questions. I don't see any question in the questions and answers frame, and also not in the chat. So I will allow to ask my first question. When you, as a Brazilian, look at the moment to Europe, Professor Neuduich just had presented the current war in Ukraine and the loss of natural gas in Western Europe, and how we are looking, where do we get gas, but we are not really looking for other alternatives. What do you think about when you see that in your horror scenarios, how we are at the moment looking for natural gas alternatives?
Yeah, that's a very good point. You know, of course, what we are seeing is how close the geopolitical issues are associated with the climate change issues and build up a sustainable society. The war in Ukraine is a clear example, you know, and then of course, one country is doing, let's say, how can I say, because of the natural gas issue to power the European economy is getting in a critical state. So this is just a reflection that, let's say, 20 or 30 years, Europe could have going to a sustainable energy pathway even in a stronger way than they have done. So it was a mistake. I think many persons recognize it today. It was a mistake because we have alternatives to the natural gas from Russia. But of course, you cannot change that in 1 year, 2 years, or even 5 years. This takes time, but the time has passed 5-10 years ago to build up a Europe that is more independent from the energy point of view. And this mistake is costing Europe a lot today. So this requires governments to have a long-term thinking.
In the Q&A session, we have now contributions, but just congratulations for your talk, not a question. but I see that Neven Dujic is raising his hand.
Thank you very much for a very interesting lecture. My question is, I'm more of an engineer and working in energy planning, and I see that energy transition is now fully feasible. So techno-economically, we could actually do it quite quickly, the mitigation, but we are not doing it, or it's going very, very slowly. What I see that the barriers are mostly socioeconomic, because there are vested interests who are investing quite a lot of funds into slowing down transition. Can we find a way how to include those vested interests in the transition process? We're thinking about offshore wind as a solution, because that is something that oil companies can work on, but it's going also very slowly.
Yeah, very good point. Let's give you one example. You know, I think there is no other country who have a renewable potential for energy as Brazil. We have plenty of solar availability, especially the northeast part. We have plenty of winds with the 5,000 kilometers of coastal area. And do you know how much Brazil have a generation in terms of renewables, in terms of solar and windy? 4%. So basically, you see that is wrong decisions by governments, you know, not just in Brazil, of course, but this does not happen by chance. Of course, the lobby of fossil fuel industry to all governments, including Brazil, are much stronger than the interest of the population per se. So basically, actually, it's big money is funding from the financial sectors that is putting billions and billions, if not trillions of dollars in the fossil fuel industry that is delaying the process for this transition. And we are paying huge amount of socioeconomic cost for the general population because of the lobbying of the fossil fuel industry to all governments. This is not particular for the United States or whatever, UK and so on, or Brazil. So we have to change this picture very, very fast with a lot of political pressure from the population itself. That is the only way I see we can change this pathway.
Then we have, you want to re-answer?
Just thank you.
Okay, then we have now a question from Rafael Belém Lavrador, and he is asking, given the correlation you showed between development and emissions, what pathways are possible to reduce inequality while reducing global emissions?
Rafael, very good question. So basically, we have all the possibilities to reduce emissions and at the same time reducing inequalities. Of course, I finished my presentation with the Sustainable Development Goals because, you know, climate change is not the only problem we are facing right now. Inequality, especially between developed and developing countries, are increasing very significantly, and this bringing stability for the global planet. And then you can imagine, you saw the scenarios for increase in temperature. Can you imagine the amount of migration from Central America to the United States or from Africa to Europe in the next 20, 30 or 40 years? Will be absolutely 10 times or 100 times more intense than today. And this will certainly bring very important instability in the political system. So basically, we have to invest heavily on poor countries for the population to stay there, giving them development alternatives and at the same time reducing global emissions. So basically, this is the only way we could construct a more stable society, a more efficient society, and a more sustainable society.
Thank you. At the moment, I do not see more questions, and so I will ask another one. What I'm always missing in the suggestions is that I'm an engineer, but I think not everything is a technical solution. What about the sufficiency? For example, the young generation, including myself, is in Europe used that all rooms are always warm all the winter. And I remember the discussions with my grandparents and also my young parents.
Yeah.
They said in winter, we only had the kitchen that was heated and the rest of the house was cold. We just couldn't afford the fuel. Don't you think that we also need maybe to rethink our waste that we are used in the young generation?
No, the change, yeah, for sure. We needed to have a strong comportamental change. For instance, we have about 2.5 billion cars in the world. Do you need that high amount of cars in the world? My city, São Paulo, has 7.7 million cars on the streets. Is this sustainable? No way. So basically, we have to change transportation, we have to change edification, we have to change a lot of things. And we know how to do it, and we are not already know what to do. So basically, what we need is public policies that could implement this change as quickly as possible. We don't have 30 or 50 years to change our consumption levels. And then that is the only way to build up a more sustainable society in terms of consumption. We have to change transportation, we have to change edification, heating, cooling, and so on. Otherwise, we will not be able to have a stable climate in the very near future.
Thank you. Now we have several questions. So when we come to the end, the one is from Sheer, one of the members of the ISC. It's a long question, so I think I need to read it. I haven't read it so far. How can the climate neutrality target be best combined with land degradation neutrality target in Brazil? Can deforestation be shifted to preserve and increase existing carbon sinks while moving to more sustainable energy, water, and environment systems? It is estimated that deforestation for pasture and soybean has lengthened the dry season locally by about 7 days more since 1980. Yeah. That is extra at the local level. Why intensifying climate change, the loss of carbon in the Amazon with the combined effect of both land use change and climate change can be about 40% in a 4 degrees Celsius world, but limited to 8% when the 1.5 degree temperature global goal is kept. Reductions in river discharge would be also 27 to 53% in different river basins in Brazil, including Rio Tabajos, and the different scenarios. All of this with key risks of food, water, health, cities and infrastructure, ecosystems, and livelihoods.
Perfect. I agree. I sign below all these issues. And then I have not explored adequately, as Sir is mentioned, is that the Amazonia is already starting to lose carbon, according to several papers, according to in situ measurements from towers in the forest, from satellite measurements that shows that Amazonia was absorbing a very large amount of carbon through photosynthesis from the atmosphere and is becoming carbon neutral, and the eastern part of Amazonia is becoming a carbon source to the global atmosphere. So this is extremely relevant because Amazonia, together with the methane emissions from the permafrost from boreal forests, are the two largest tipping points from the climate system. If you don't stop this process right now, decreasing the increase in temperature and the changes in precipitation, this will be impossible to stop the process of forest degradation, as the question mentioned. And that is very, very clear. And we are really emphasizing the need not only to reduce deforestation, that you have to do it immediately, as quickly as possible, because it's by far the cheapest, fastest, and easier way to reduce emission. But if we zero deforestation and the developed countries and the rest of the world continues to emit 40 to 50 gigatons of carbon per year, so the Amazon will have no chance of surviving in the near future, and then we could have an aggravation of climate change very quickly and very seriously.
And then we have an anonymous participant, and he is asking, for your presentation, we can infer that the great responsibles are the rich and developed countries. How can they make changes in their economy and society so that underdeveloped and poor countries can develop? It seems that Brazil has more clean energy, and yet very occasionally we see people, many times even celebrities, blaming Brazil from developing, using, and advancing in our land. Many times for me it seems more exploitation and submissions for us, and they living as they want by them. What do you think?
I think that is not the issue of blaming one or the other, developed or Brazil or the holding of tropical forests. Basically, we will need the help of joint work of everybody, developed and developing countries. Without this, I don't see any possibility for us to get out of this climate crisis. And it's important to know that the issues of the developed and developing countries are intrinsically linked. I try to show this in my presentation. So it's very artificial to separate both issues. We need governance actually to deal in a quite equilibrated way the reduction of fossil fuel emissions from developed countries, reduction of deforestation in tropical countries, Brazil, Indonesia, Congo, and so on, as well as to change the level of global consumption for everybody, for the 7.7 billion people. The level of consumption we have right now is completely unsustainable, even in the very short term. And this has to change. And this will change the whole economy that is based on infinite economic growth forever. And this is impossible to have in a planet with the limited natural resources. So now we are facing a very clear deadlock, let's say, so we have to act very quickly, and the scientific community have to go ahead and warn as much as possible the societies and governments where we are going to.
Paulo, we have two very short questions to finish the session. And the first one is coming from Maria Amelia, and she is asking, do you think electric cars would be a solution for Brazil?
Electric cars will be a solution for everybody. Of course, the future of individual transportation will be electric. It will not be, the cars we have that are based in 100 years old technology. The issue is that in my city in São Paulo, if you change 7.7 million cars powered by gasoline or ethanol by electric car, you will still have a tremendous problem. We have to invest in transportation for mass transportation systems. We have to change the whole philosophy of individual transportation in cities with the shared cars, much smaller cars. We don't need to transport 2.5 tons of steel and batteries to transport an 80 kilograms person. So this is stupid. And that is exactly what we are doing right now, and these have to change.
And then I think it's an excellent last question from Beatrice. And she's asking, in your experience point of view, will humankind be able to stop or reduce climate change? Are you optimistic?
The clear answer is yes. We will win this fight. And why I think that? We do not have any other alternative. Do you have a plan B other than not change the climate to a dangerous level? No. So basically, we will win this crisis, but it will not be easy. There will be losers, there will be winners. This will change the global geopolitics. We need the governance, global governance, to deal with things like that, because the United Nations was not designed to do that. So we have tremendous challenges to go ahead. But the final results, in my opinion, will be a society that fulfills the 17 Sustainable Development Goals, because we do not have a plan B. We don't have a planet B where we could move everybody out from planet Earth. So basically, we have to solve this issue as quickly as possible here. And in my opinion, we will do it.
That is great that you're so optimistic after your horrible slides you have presented. I think it's a good point to stop here. I would like to thank you once more, Paulo. And I'm not sure whether Rita wants to take over to finish the day.
Thank you, Ingo. Nevin, do you like to finish the session, or may I do this?
Please finish. Yes.
Okay. Thank you, everybody. Thank you, Paulo, for your very, very interesting presentation. Was very, very alarming, but it was fine for us. I think we need this shake to take some actions. Then it was very appropriate. Thank you very much. And thank you very, very much, everyone, all the attendees for this first day. And I hope to see all of you tomorrow and enjoy the conference, see the presentations in the site, in the website, for the others participants, and see you, all of you, tomorrow. Thank you, Ingo. Thank you, Nevin, for all.
Thank you. Bye-bye.
Bye-bye.